Hello everyone. In today's video, I will show you how to solve the minimum deletion cost to avoid repeating letters on LeetCode. So let's take a look. Given a string s and an array of integers, where cost I is the cost of deleting the ith character in s, return the minimum cost of deletion such that there are no two identical letters next to each other. Notice that you will delete the chosen characters at the same time. In other words, after deleting a character, the cost of deleting other characters will not change. Okay, so let's look at the example. So the example has A, B, A, C. So in this case, we want to delete one of the A's here. So if we see is the deleting cost is 3 and 4, and we want the minimum cost, so we choose the min of the two. So the algorithm here is I'm going to start from the first two characters, and then we compare if it's the same. So I'll give it as I is on the left and J on the right. So if the two are the same, we want to add the minimum cost to the result and then move forward. But when we move forward, we need to know, okay, which one we actually move. So let's say we have two A's and it's 3 and 4. So what we want to keep is we want to keep the 4 because we already deleted 3. So we need to advance I to the index J, and then index J increment by 1. So let's take a look at the code. First, if the length is less than or equal to 1, we know that we don't delete anything. So we just return 0. And then I initialize I and j to 0 and 1 and result to 0. And then I'm checking if I is less than s dot length minus 1, which is the index like 1 before, because we need at least 2, right? And then j less than s dot length. So like I said, I compare si with sj. If it's not equal, so we know we can move it one step. So we can say I equal to j and then j plus plus. So we just shift I to the j index and then advance j. If si and sj are equal, what we want to do is we want to get the minimum cost of cost I and cost j and then add it to result. So one tricky part here is if we know that cost I less than cost j, that means we need to shift the I to the j index, and then we advance j as before, and just keep doing this one. So the reason for this one is like I will give you some example. So if you have like you have multiple A's, so you have A, and then the cost is like 1, 2, 5, 4, 3. How many of them? 1, 2, 3, 4, 5, 6, 2, 8. So first we compare 1 and 2. We know minimum cost 1, so we need to change I to this index. If we don't do this, like I equal to j and keep the I at the same index, is if we compare 1 and 5, right? We don't want that because we always get rid of the the min one and keep comparing this one instead. So let's try to run it. 82% and 89% memory, not bad. I think we could improve a little bit, but we don't it doesn't matter in the interview because we normally don't run it. We can see it. Let's see. Here you just do big O of n because you loop through the whole thing, just one loop, right? Just add one ij to the end. And memory is actually use only I, J, and resolve. So memory is really little and is all one. And that's it for today. Thank you so much for watching. Please hit like and subscribe to my channel. It will help me a lot. Thank you so much. Bye bye.